Let's move into a bit of a game. Huh? Before we do, a little quick thing. Where are the following continuous? I'm curious. Do you know what any of these functions look like? Like, do you know cosine? Not cosine of x squared. But I want you to assess for yourself. Do you know what any of this stuff looks like? You know what a natural log looks like? Do you know where they're continuous and where they're not? We gotta work on this, okay? Well, there's a beautiful thing about cosine. Let me draw cosine for you. I've drawn it for you before. We'll look at that beautiful graph, huh? Goes on and on and on. It's terrible. It's a terrible graph. But it goes on forever. No, so they didn't put any x values or y values. Just get you the idea. It's continuous everywhere. What do you think x squared? You think x squared is continuous everywhere? So as long as you got a continuous function inside of a continuous function, that's just continuous. And I don't know how to graph cosine of x squared. That's a total lie. I do. But even if you didn't, as long as you know that those two functions are both continuous, what the hell you give a crap about? You're good to go. You're good to go. Continuous and continuous is continuous. We're good. All right, let's move to our next one. Let's get this crap out of here. Now, for number 2, the natural log. The natural logs. Let's draw in the natural log. Everybody's got this one down, right? You got it down. This is one of our parent functions that we should add. Thanks, Surface. It shouldn't be looking like that. It should be straight. I promise. I actually don't drink. I don't have the shakes. It's my $1,000 machine that does not work. I have another one. That one doesn't work either. And then I broke my other Surface as well. It's about time to move to Mac, or some sort of Apple. You know what I mean? Maybe a little iPad. I don't have to learn all that shit. So sorry for complaining to you. But this is bullshit. I can't do anything to Microsoft except talk shit about them the whole time to all of my students. So that's the way I get back at them for selling me a piece of shit. Okay, so there's our natural log of x. Sorry about that. Y equals the natural log of x. But what we should gather from this, again, is we're only allowed to have inputs that are positive. Look at our x values. As our x values go this way, right? That's from 0 up to anything, but we don't include it, right? We don't include it, so we never touch it. There's an asymptote there. So we're going to take off and go this way. So we're saying, all right, this 1 plus sine of x inside of here? No. That thing can't be 0, and it can't be negative. So let's do this. Let's see if we can't do something. Let's just take it out. The argument, what's inside of there, 1 plus sine of x, and just set it greater than 0, and see if we can't solve that thing. And you're like, move the 1 over. So we say sine of x needs to be bigger than negative 1. Well, okay. Okay, that's not that bad. We need sine of x to be bigger than negative 1 for our x values, but sine waves look like this, right? Kind of like that. That's a sine wave. Starting down at 0, where the heights go up to 1 and at negative 1. Oh! You mean these points down here? It just can't. It can be anything above there. It just can't be that. That's the smallest value. If we only knew where that was, and that's at negative pi over 2, and that's at 3 pi over 2, and that's at add 2 pi. That's 7 pi over 2. So we could say that this is continuous everywhere. Let me write this in. Continuous everywhere except x equals, and I'm going to write it in as negative pi over 2 plus 2 pi k for k, the element of any integer. So that k, the element of any integer, k an integer, 1, 2, 3, 4, 5, 6, 0, negative 1, negative 2, negative 3, negative 4, whole numbers, positive or negative. So we're saying that if you add any multiple of 2 pi to that negative pi over 2, bang. So it's continuous everywhere except there. That's just getting you used to a little bit of notation. You don't have to write that way yet, but you will soon. And then sine inverse of x, it's continuous everywhere on its domain. Do you know its domain? It's negative 1 to 1. Yeah, I need to get something different. That's ridiculous how it's writing right now. So, there we go. That's just wanted to talk. You're not going to be tested on this. This isn't a problem you find. I just want to build this up to get us better with these problems, with other problems. Now here's the game I want to play with you. You have a couple in your homework like this, maybe not to this level, so I'm showing you something that's a little bit more challenging than what you might find in your homework, but these are homework-like problems. We want to find a and b such that our function here is continuous for all real numbers. All right. So a's and b's, we want to go find them. So where we got our a's are here and here. And our b's, we want to find they're here, here. Oh, they're in all three. We got b's in all three of them. And it's a piecewise function. We read piecewise functions right to left, not left to right. Because they tell us where. It tells us our domain. We're like, hey, when our values of x are 2 or bigger, we're going to use this function. When values are between -1 and 2, our x values, we're going to use this function right there. And then when our x values are less than or equal to -1, we're going to use the other. Right? So we have those. And I know you even had to deal with a piecewise function before. So I'm going to kind of put it on a number line here. Go -1 and 2. So what it's saying is, if you're less than or equal to -1, we're using this function. If you're in between -1 and 2, you're using this function. And if you're using 2 or bigger, you're using ax plus b. That's a piecewise function. It's just telling you what the function is going to be. All right, but whatever. That's not the point of the game. That's not the point of the game. All right. Just thought I'd talk about it since I didn't like piecewise functions when I was a student. I thought they were a pain in the ass. Now I'm not so bad with them, but I can see where you not like them. All right. Let's go tackling this problem. Now, first find out it's continuous. It's at these points right here. See this -1? We're going to need to be able to plug -1 into both of these and have it equal the same thing for it to be continuous. Because the height, the y values would have to be the same, right? So the y values aren't at the same height. You're going to end up with something like this. Well, we got to make sure they're at the same height, which means the whole things must equal each other. So what we're going to do for our first step is we're going to say 4b plus 9x plus a, what's right down here. And we're going to set it equal to what's right above it, the bx squared. The bx squared. Except we're going to plug in that little value right there. Let's look at it when x equals -1. So we get 4b, and then when we plug that in, you get plus, and there's that -1 plus your a is equal to b times -1 all squared. So what do we get? 4b minus 9 plus, sorry, my a's and my 9's look similar. I'm trying to make them not, and then we just get is equal to b. Okay. Maybe we get all this stuff together. I'm going to subtract over something just to get some sort of combination. So -9 plus a is equal to -3b. Okay, so we have some sort of connection. I'm going to keep that there. We're going to come back to that in a second. All right, now let's go look at the combination of these. Well, this and this must equal themselves at 2. So let's set those two equal to each other and then plug in x is equal to 2. Now I'm going to jump the step here. X is equal to 2. And when we plug it in, that's going to be b times 2 squared. And we set that equal to a times 2 plus b. Well, this is equal to, what's that? 4b is equal to 2a plus b. We'll subtract that b over and we find out 3b is just equal to 2a. Okay. Well, wait a second. We have two equations with two unknowns. I think we can go and solve for them. And, oh, how freaking convenient that 3b and 3b is sitting there. Granted, one of them's negative, so let's go get it. So it's -9 plus that a is equal to negative of, and now replace your 3b in with 2a. So we have -9 plus a is equal to -2a. Let's subtract our a over, get our a's away from everything. So we have -9 is equal to -3a. Divide by -3 and we find out that a is equal to 3. We found a. Well, shoot, just plug it on into there. We're almost done. So we have 3b is equal to 3b is equal to 2 times a, and a is equal to 3. So we have 3b is equal to, well, come on. And b is equal to 2. We did it! Woohoo! It's a fun game. You're getting to play that one. I sometimes put them on tests. I sometimes don't. But that for sure is how it's going to be in your homework. So know it. Love it. Kick butt with it.